In the last video, we calculated some distances between points in the xy plane, and even ventured into distances in space using the theorem of Pythagoras applied to certain right-angled triangles. In this video, I'd like to step back a little and just consider distances in the real line. In the last video, all of the diagrams used positive numbers or zero implicitly. Now I'd like to introduce an apparatus for dealing carefully with all numbers, whether they're positive, negative, zero, or mixtures of positive, negative, and zero. We'll look at the notion of absolute value or magnitude of a real number and some important related techniques. Absolute value or magnitude captures precisely the notion of distance along the real line. Let x be a real number. Define the absolute value or magnitude of x to be this symbolism with x inside two vertical lines, and that's equal to x if x is greater than or equal to 0, or minus x if x is less than 0. And this is just the distance between x and 0 on the real line. Well, how could that be? Well, here's the real line with 0 in the middle. If x is greater than 0, then the distance between x and 0 is just x itself, which matches the formula for the absolute value of x. If x is less than 0, then the distance is minus x. Remember, x is negative, so minus x becomes positive, again matching the formula for the absolute value of x. If x happens to be 0, then the distance, of course, is 0, which is, by definition, the absolute value of 0. For example, 1 and minus 1 are both 1 unit distant from 0, so their absolute value is 1. 2 and minus 2 are both distant 2 from 0, so their absolute value is 2. 1.5 and minus 1.5 are both 3 on 2 units from 0, so the absolute value is 3 on 2. And of course, as we've observed, the absolute value of 0, the same as minus 0, is 0. It's an important and useful fact that the distance between two numbers is the absolute value of their difference, and it doesn't matter which order you take the difference. For example, if x is greater than y, so x appears to the right of y on the number line, then the distance between them is just x minus y, and that's the absolute value of x minus y because it's positive. If x is less than y, then the distance between them now is y minus x, which is the negative of x minus y, and that's by definition the absolute value of x minus y. And in the final case, if x equals y, then the distance between x and y is 0, and that's just the absolute value of x minus y. For example, the distance from 2 to 4 is just the absolute value of their difference, which is 2. And you can see this on the real line. If you draw the point 2 and 4 on the real line, you can see that the distance really is 2 units. On the other hand, if we look at the distance between, say, minus 2 and 4, that's the absolute value of the difference, which turns out to be 6. And you can see that directly on the real line. The distance between the two numbers turns out to be 6. Right. Here's some practice for you. I want you to solve the following equation. That is, I want you to find all x distant exactly 3 units from 2. Okay, so here's the solution. Let's draw the line and locate some points. In particular, let's locate the number 2 and look for all the points that are distant exactly 3 units from 2. In fact, there's 2 possibilities, whether you move to the right or the left. If you move to the right, you find the number 5. And if you move to the left, you find the number minus 1. And so the solution set just consists of the two numbers minus 1 and 5. Let's vary the previous exercise by turning the equation into an inequality. Let's replace equals by greater than. Okay, let's solve it. Here's the diagram from the previous solution where we had equals, but now because we've got greater than, neither minus 1 nor 5 are solutions. So we want to exclude them, so we'll draw little circles around them. Now we want the distance to 2 to be more than 3, so we'll move further away from 2, either to the right or to the left. And then we can read off the solution set. It's just a union of 2 intervals. One interval extends indefinitely to the left from minus 1, but not including minus 1. And the other interval extends indefinitely to the right from 5, but not including 5. And we put those two intervals together with a union symbol.